Okay, the limit definition of the derivative is what we have here on the right side, and it's basically a like it starts off with the slope formula where like the top f of x plus h is like a y2, right? It's like a y coordinate of the second point. F of x is y1, right? So it's y2 minus y1 on top, and then on the bottom x plus h minus x, which are your x2 and x1 respectively, leave you with h. So what it's essentially doing is taking the slope formula and making it better and better by bringing the 2 points closer and closer together, and that's what the limit as h goes to 0 is. So what you have to do is basically come up with expressions for f of x, which is given to you, and then f of x plus h, which you get by replacing x with x plus h. So the actual calculation f prime of x, so we're going to plug in to the limit as h goes to 0. We're going to plug in our f of x plus h, which is this guy, x plus h plus b, right? And we're going to subtract off our original expression, which is f of x, as mx plus b. And we're going to divide the whole thing by h. Right? Now it just ends up being some algebra, right? You say, so you're still doing the limit as h goes to 0. If we expand this and distribute the m, we end up with mx plus mh plus b. And we distribute the negative sign, so we get minus mx minus b, right, all over h, right? If we cancel some stuff out, right, the mx cancels with minus mx, the b cancels with minus b, and the simplified form of this would be the limit as h goes to 0. Simplified form is mh over h, right? And since there's only one term on top and bottom, we can cancel out these h's, which just leaves us with the limit as h goes to 0 of m. And since m is a constant, it doesn't even matter that h is going to 0. The limit of as h goes to 0 of m is always going to be m.